Okay, so welcome everyone, welcome to my channel. So I'm here to solve these questions. Okay, so they are quite lengthy, so I will divide these videos into multiple sections. There will be multiple successive sections, okay, because I can't solve it at once. Okay, so here you have quite a lot of questions, but the topic of the day is implicit differentiation. So implicit, we've done part of it. So for those who have not seen the previous video, you can quickly revise it before you watch this one. Okay, so you have 3x. This is question 1. 3x squared plus 5. Okay, then you have sine 2x, and you divided by x root of 1 plus x squared. Okay, so you're taught to differentiate this. So here you know that when you have two functions divided, or you have a numerator and a denominator, the easiest way is the quotient rule. Quotient rule. So what does the quotient rule state? So if u over v are functions which you are supposed to differentiate, then therefore you keep v constant, differentiate u, subtract, differentiate v, keep u constant, then v squared. Okay, so here the numerator of this function will be set to equal to u and the denominator v. So u is the numerator, which is 3x squared plus 5 sine 2x, then v is the denominator. Okay, 1 plus e to the power x. So for those who have not watched my previous video on indices, please do that, so that e to the power 2x, this is same as 1 to the power half. Okay, so hope you guys, if you haven't watched indices, please do so before you get confused how we've moved from here to here. Okay, great. So now we have these two equations, so we have u and v. Okay, so now you know, for us to use this formula up here, we need to find u prime and v prime. So if you take u, for example, this, you take u for example, it also comprises of two functions multiplying with each other. So we use here, what do we use here? Product rule. So product rule, again, it uses symbols u and v, so I'm trying to avoid that. So we'll say, let's say if you want to differentiate functions multiplying each other, you differentiate a, keep b constant, then you add, you keep a constant, differentiate b. Okay, so we'll divide this function. You set first part equal to a, second part equals to b. So a equals to 3x squared plus 5. Okay, then b equals to sine 2x. So what's the derivative of a prime? We are differentiating this function. So how do we differentiate? Bring down the power, so it will be 3 by 2. This power comes down. Then x power minus 1, so it will be 1. Differentiating a constant is what? Is 0. We know that. Okay, by now we know. Okay, so 3 by 2, which is 6, so this will be just 6x. Then we come to b. So b prime, how do we differentiate sine function? Derivative of a sine function is cosine, the same function. Then you differentiate this one, this term here. What's the derivative of 2x? It's just 2. I said if x has an order of 1, its derivative is this coefficient. Okay, so you just get 1 here, unless if it was 2 here or powers more than 1. Okay, so now we have this, meaning we can get our u prime, which is this function. Okay, so let's say ab prime equals to, so a prime, what is a prime? A prime is 6x. What is b? B is sine 2x. Okay, plus what is a? A is 3x squared plus 5. Okay, what is b prime? B prime is 2 cos 2x. Okay, let me just write it nicely. So you have 6x sine 2x plus the 2 can come in front. Okay, so 3x squared plus 5 and cos 2x. Okay, so this is AB, but you know AB is what? AB is u prime. We're just differentiating u. So u prime is 6x sine 2x plus 2 plus 5 cos 2x. So this is our u prime. So we'll do the same for v now. V is this part. So v is okay, so I had rewritten this as e power x, then 1 plus x squared to the power half. Okay, so I was rewriting it in this form because I know chain rule works better if we have a power like this. Okay, so v is e to the power x, 1 plus x squared and to the power x. So great. So here again, for us to get v prime, we have two functions multiplying each other. So we use the same form notation AB multiplying each other. We'll have a prime b plus a b prime. Okay, so let's set our a is what? Our a is e to the power x, and our b is 1 plus e squared to the power 1 over 2. Okay, great. So a prime exponential, this one, integrating it or differentiating it is just the same, so it's just e to the power x. Okay, that's your a prime. Then b we use chain rule. So how does chain rule works? Okay, so b prime, chain rule, you bring down the power, same thing. So you bring down the power. Okay, okay, so hope you're following. You bring down the power, this power here, this power, you bring it down, then you subtract the power by 1. Okay, so this is how it works. So you bring down the power here, half, then you write what is inside. Then now power minus 1, so it will be half minus 1. Then you multiply this by differential of inside the brackets. Okay, so this is how power works. You bring down the half or the power here down, rewrite whatever was here, then subtract the power by 1, then multiply by the derivative of inside the brackets. So differentiating 1 is 0. Differentiating x to the power 2, we bring down the 2 and subtract the power by 1, which is just like this. Okay, so b prime is equal to, so you have 2x over 2 this one, then you have 1 plus x x squared to the power half minus 1, negative half. Okay, so b prime equals 2 to cancel, so you have x 1 plus x squared half. This is negative. So you know, you agree with me, those who revise indices, that this is same as x over 1 plus x squared power half, which is same as x over root of 1 plus x squared. Okay, so this is our b prime. So now we have these equations. Now we can get ab prime. Okay, so ab prime here, we say a prime is e to the power x, so a prime is e to the power x. Then what is b? B is this function here. Okay, so b is 1 plus x squared power half plus, okay, a is just e to the power x, so a. Then b prime is this function, so we can say dot x over if you want, you can rewrite it like this with the power of negative anything. Yeah, so here we are getting v prime, so this is not a b, it's v prime. Okay, so this is, we can take out the e, then we say 1 plus x squared, this is power half, plus x over 1 plus x squared. Okay, so this is our v prime. So if you follow, we are trying to solve this equation. So we set this equal to u and we set this equal to v. So for us to find the desired answer, we need to use this equation because we have u over v. So this is the equation we have to solve. So we're getting u prime and v prime. So now we can apply the quotient rule to get the answer. Okay, so now quotient rule, u over v prime is equals to v u prime minus, okay, u v prime over v squared. Okay, so now let's put everything in this equation. So what is our v? So let's see, v is what? V is this equation here. Okay, so write our v. Our v is e to the power x power half. So this is same as e to the power x 1 plus x squared. Okay, which one is better? Okay, let me just write it. Okay, so let me write it like this, 1 plus x squared. Okay, so this is my v. This is multiplied by u prime. So what is u prime now? So u prime, we found u prime. U prime is this giant equation here. So 6x sine 2x. Okay. So 6x sine 2x plus should be 3x squared plus 5. Then let me check the last part. Okay, is okay, cos 2x. This is cos 2x. Okay, so this is just this part, then minus okay minus, so this is just a numerator, so minus u. What is a u? What is our u? Our u is, okay, 3x. Okay, so our u is okay. Then what is our v prime? Our v prime is this giant equation here. So we say multiplied by e to the power x. Then I can write it as 1 plus x squared, like this, which is this part, okay, plus x over 1 plus x squared. Okay, so this is just the numerator, then divided by everything divided by v prime, v squared. So what is v? V is this squared. Okay, so v is e squared. Yeah, so what can we do here? We further simplify. Let's see, is there anything similar? So I can see e to the power x, this one is common on the numerator, okay? So meaning on the numerator we have e to the power x. So here everything will repeat except this part. So how 1 plus x squared, just have to make the equation compact. 6x sine 2x plus ex squared plus 5 cos 2x minus, so everything here will repeat, so we'll say 3x squared plus 5 and sine 2x, and then we have 1 plus x squared, this part, plus x over 1 plus x squared. So we close the bracket here. So you don't have to do this. If you just reach here, you can leave it. So the denominator, you can further simplify it, because this can multiply by 2. It will be just e to the power 2x. Okay, then we have this part, which is 1 plus x squared. We write it in this form. Okay, so you're also squaring, you're multiplying this by 2. Okay, so a 2 and a 2 will cancel. So that's what I wanted to show. So meaning this equation will just be 1 plus x squared, just like this. Okay, yeah. Then now we have e on top and e down, so the powers are same. So we have the base. If the bases are the same, you subtract the powers. So let's say you have let's say 2 to the power 2 over 2 to the power 3. Here you have the same bases, 2 and the 2. So meaning your answer will be 2, then 2 minus 3, which will be just 2 to the power negative 1. This is same as 1 over 2. So same applies here. We have e to the power x over e to the power 2x. So you subtract the powers since the base is e. So meaning you have e, then you have x minus 2x, which is e to the power negative x. Okay? This is same as 1 over e to the power x. So in short, this one on top will cancel. We'll just have e to the power x. This is what I was showing here. So this is a very giant equation, okay? So kindly take time to go through and understand what we were doing here. So the final answer, this will be, so we'll remove the 2 here. In this part we have shown how it reduces to this. Okay, so this will be your answer. Okay, so this will be your dy dx. Okay, so thank you for following. I think for this part of the video we'll just solve question 1. So I'll make another video for question 2 because I don't want them to be very long. Yeah, they don't have to be very long. So yeah, thank you for following. I'll solve question 2 soon. Okay, so thank you. Continue subscribing and liking my videos. So make sure for you to understand these concepts, you need to watch each and every video I post. So I have 2 playlists. There's one for grade 12s and one for diploma mathematics. So you can go to a particular playlist, then watch the particular videos. So thank you.